Hi there, today's topic is inverse of a matrix. This is the most important topic of matrix in which we have to find inverse. A inverse is A inverse equals to adjoint of A oblique determinant of A. Let's take the steps to find it. First one is take the determinant of A, and second one is take cofactors of A. Third one is make the transpose of these cofactors. Fourth one is apply the formula A inverse equals to adjoint of A oblique determinant of A, and you will get the result. You must have to write down these steps, and as these are very important to find A inverse, right? So let's start with the question. Question is find inverse of A when A equals to A is given as 1, 3, 4, 2, 4, 5, 3, 1, 2. You can check my previous lecture as well, in which I had given the same value and we found the determinant of A. Let's do it again. Okay, it's very simple. A determinant equals to 1. By deleting first row and first column, we are getting it's a 4, 5. By deleting first row and first column, it's 4, 5, 1, 2. 4, 5, 1, 2. Minus 3. Again, by deleting the same row, by deleting the same row and same column, we get 2, 4, 2, 5, 3, 2 plus 4. It's a 2, 4, 3, 1 equals to I'm solving it. You must have to solve as well. So we got the value minus 4 as a determinant. Next one, let's find the cofactors. Second step is find the cofactors. I'm writing over here. Second step, that is find cofactors. Cofactors are, for example, A11 equals to minus 1, 1 plus 1. See the value, it's A11, take its cofactor, submatrix, that is 4, 5, 1, 2. Right over here, 4, 5, 1, 2. And let's solve it by cross multiplication. One important thing which must be understood, that is 1 1 it's a plus, 2 means plus, 1 means minus, 2 means plus. So that means plus is a plus. So A11 is plus 3. Next one is hold on. Let's find cofactor of A12 means first row and second column equals to, again I'm taking the value as the value is A12 is first row and second column. This is 3. It's a minus 1, 1 plus 2. Again its symmetric will be 2 5 3 2. 2 5 3 2. Let's solve it again. Equals to, so we got the value minus 11. But see, for cofactors it's a 2 plus 1, it's a 3. 3 means minus. Minus is plus. So it will be plus 11. Next one is first row and third column, and it will be, sorry, my screen is a little bit short. First row and third column. First row, third column. Then it's minus 1, 1 plus 3, 2 4 3 1. It will be minus 10. Again for A21 equals to, please write the value at your side page. A21 is minus 1 2 plus 1, and its value is, by deleting the same second row and first column, we got 3 4 1 2. As we got the value 2 plus 2, but see over here 2 plus 1 means 3. 3 means minus, so minus plus is minus, so it will be minus 2. Again for A22 it will be minus 1 2 plus 2, second row and second column. The value will be 1 4 3 2. Let's always minus 10. So we got the value minus 10. Again A23 or second row third column, it is minus 1 2 plus 3. So take its submatrix, it will be 1 3 3 1. 1 minus 8. So 2 plus 3 5. 5 means odd, that means we will get the value 8 as positive. Next one is A31 equals to third row first column, 3 plus 1. It will be 3 4 4 and 5 equals to, let's cross multiply, minus 1. It's a 3 plus 1 plus minus minus, so it will be minus 1, which will stand. Again for A32 or third row second column, it will be 3 plus 2, and let's take the submatrix of this. 1 4 2 5 equals to -3. Then it's a 2 plus 3 plus 2 5. 5 means odd, minus minus is plus, so it will be plus 3. Again A33 or third row third column, it will be -1 3 plus 3, so its submatrix will be 1 3 2 4, which will left, equals to -2. 3 3 is a plus, plus minus is minus, so we got the cofactors as, we can write over here cofactors as, first cofactor A11 is 3, and then it is 11 and -10. Again -2 -10 plus 8, -1 3 and -2. For finding adjoint, we must have to transpose these cofactors as rows into columns. I am putting over here, this is, I am putting first row as first column, 3 11 -10. Again second row as second column, -2 -10 and 8. Third row as third column, -1 3 and -2. So we got the adjoint of A. Now to find inverse of A, we must have to put the values of these. So we can work out over here, I am just drawing a line. We can do as A inverse equals to adjoint of A oblique determinant of A, equals to, let's put the value of adjoint of A, 3 -2 -1, 11 -10 and 3, -10 8 and -2. And put the value of determinant. The value of determinant was -4, so we got these values. Now what we have to do to find A inverse equals to, put the values 3 oblique -4 and try to solve these. -2 oblique 4 -4, -1 oblique -4, 11 oblique -4, -10 oblique -4, 3 oblique -4. Again -10 oblique -4, 8 oblique -4 and -2 oblique -4. Equals to, let's summarize, it will be 3 oblique -4, that will be same, so answer will be 3 oblique -4, and then -2 oblique -4 is 1 oblique 4, as they cut to each other. Then again it's -1 oblique minus 1 oblique minus 4, then the value will be 1 oblique 4. Hold on. Equals to A inverse equals to minus 3 oblique 4, then 1 oblique 2 and 1 oblique 4, then it will be minus 11 oblique 4, then afterwards it will be 10 oblique 4, that is minus 10 oblique minus 4, that will be 5 oblique 2, again minus 3 oblique 4, then again 5 oblique 2, as it cuts 5 and 2, then 2 oblique 1, that means we got the value as minus 2. There is a minus at the downside, and 8 oblique 4 is minus 2. Then 1 oblique 2, as minus 2 oblique minus 4 is 1 oblique 2. So this is answer. So we got the value A inverse equals to this is answer, right? Thank you very much. Try to do a little bit more practice in this. Thank you.